Hello, this is the 12th video on electricity and magnetism for classes 6 to 10. It can be used by students of class 10 to review and to understand. In this video, we will look at what is known as the Leyden jar. It's a device to store large amount of electric charge. Instead of generating it every time we need it, we can also generate electric charge and store it and then use it later. In the previous video, we learned about induction. We saw Faraday's ice pail experiment, which had two important results. One result was that the inducing charge and the induced charge are equal. They are of the same magnitude. And the other result was that when you place charge on a metal object, the charge resides completely on its outermost surface. Let's also remember these two facts. The charge can be transferred from an insulator to a metal object by touching it, from a PVC pipe to a metal object, for example. Charge can also be transferred from one metal object to another metal object. We have seen this. Okay, now let us address the problem of storing a large amount of charge. Just like we can fill up a large water tank by fetching buckets of water and pouring it into the tank. So if we can pour 100 buckets of water, then the tank might fill up. Similarly, we might, every time we rub a ebonite rod or a glass rod, we generate small amount of static electricity. We want to store this into something like a water tank. So when we try to do, so we can try to store this charge on a metal object. So every time we rub and generate charge, we can transfer the charge to the metal object and use it as a store. But there is a problem. Okay, so the first few times, when we bring in a charged PVC rod and touch it to the metal object, the charge will very easily transfer to the metal object. But as we keep doing it, it becomes more and more difficult to transfer the charge. So we can understand this problem using an analogy. So the analogy is this. There are two columns of water here. You can think of them as glass pipes. Yes, and there's a separator. So now I want to transfer the water from the column on the right side to the column on the left side. Okay, so when I remove this block, then water will flow from the right to left. But not all the water in the right side column will flow. Okay, so water will flow only till the two levels become equal. Now, if I want to transfer any more water from the right column to the left column, then I have to pour in more water in the right column. So the height increases, and then remove the block, open the connection. Then again, some water will move to the left column only until the levels become equal. So like this, as we keep transferring more and more water, we have to do a lot of work. You can imagine climbing a staircase all the way and then pouring the water there. And then some water will be transferred to the left side column. Okay. So similarly, when we generate charge by rubbing, and we want to store it on a metal object. So here is a large metal sphere sitting on an insulating base, and that is our store. Every time we rub this, on the right side, we have a small, we can think of it as a glass rod, rub it with silk. So some charge is generated. So we want to transfer that charge onto the storage sphere, metal sphere. So first few times the charge will very easily jump to the storage sphere. But then as more and more charge is transferred, there will be forces of repulsion. So when you bring in this charge on the glass rod, the charges which are already there in the store, and this storage sphere, they will repel, and the charges will not get transferred to the storage. So it's like pushing more and more people into an already crowded coach. So the people who are inside already will resist the newcomers. Okay? But if there are people inside who can help by pulling the newcomers, then we can fit in a few more people. Okay, so how do we do this kind of thing, with respect to electric charges? So we have to use induction. Remember induction? So when you bring in an external charge, and then the charge is inside a conductor. Like this is a metal object, a conductor, which is filled with positive and negative charges. But when an external charge comes close to it, these charges will get separated. Okay, so the unlike charges will get attracted to one end, the like charges will get repelled to the opposite end, and the charges will separate. We have seen this. This is induction. So we set up a mechanism here. Here, look at the sandwich. So in between, I have an insulating sheet. On either side of this insulator, I have two metal sheets. We can think of them as copper sheets. And the sheet on the left is connected through a copper wire or any other metal conducting wire to the ground. So the idea is to use this right-hand side metal plate, copper plate or whatever metal plate, as the store of charge. So we are going to charge by rubbing. So here in this case, I'm using a negative charge, that is, I may have rubbed a ebonite or a PVC rod. So whatever charge is generated, I want to transfer it to this metal plate on the right side in this sandwich. So we do this after a few times, then there is charge on this right side metal plate. And because of the presence of this charge, the left-hand side, the metal plate on the left-hand side experiences induction. Induction happens, charges will separate in that plate. So because of the insulator, these charges will not combine. Otherwise, they would combine and they will cancel each other, plus charges and minus. But because the insulator does not allow the charges to move through it, but the insulator allows the force to be felt. So the metal plate on the left side will feel the force of attraction and repulsion. The charges inside it will feel the forces. So the positive charges will gather at the one end, and the negative charges will go to the far end. And then because there's a connection to the ground, these negative charges, they would like to run away from these negative charges on the right-hand side. So they reach the ground, they move away. And the positive charges are left there. They're trapped, they're held captive by the negative charges on the right-hand side plate. So once this happens, we can see how this is helpful. These positive charges are like the helpers. So when we bring in more negative charge to put it onto this right side plate, so the negative charges are repelling them, but very close to it, close to these negative charges, we also have positive charges, same amount of positive charges, and they are attracting it. So there's a force of repulsion, there's also a force of attraction. So on the whole, these incoming negative charges don't feel much repulsion, so they will move on to the plate. So this way we can keep like fetching, just like we can fetch buckets full of water, we can in small quantities, we can bring in large charge here in small quantities many times and transfer all that charge onto this metal plate. So at the end of it, a lot of negative charge will end up on the right side plate, a lot of positive charge will end up on the left side plate, and the negative charges on this left side plate will simply vanish. They will go away to the ground. They will flow to the ground. We are left with a large amount of negative charge on this right side plate and a large amount of positive charge on the left side plate. They are separated by the insulator. We can do this whole thing we can also store positive charge. So we can bring in a lot of positive charge little by little and store it on this right side plate, in which case the charge separation will operate in the opposite way. So the negative charges will stick here and the positive charges will move away, and those positive charges will get cancelled because the negative charges will flow in. The electrons, the mobile electrons, will flow in from the ground and cancel those positive charges. So the ground is a reservoir of charges. You can send any number of electrons, negative charges, to the ground. You can also draw up any amount of negative electrons from the ground. Okay, so this is how this arrangement works. So now this arrangement is used in the Leyden jar. So how does it look? The Leyden jar it has two metal cups which fit one inside the other with insulating cup in between. So that insulator could be glass, plastic, or PET, or any such material. So this brown, what we have in brown here is the insulating cup, and inside there is a metal cup. We can think of it as a copper or a silver cup. Outside, snugly fitting, there is also a metal cup, and the outer metal cup is connected to the ground. And here we have a metal bar with a knob at the top, a stem, and then a flexible chain which will touch this inner cup. Okay, so the inner cup here is the right side of in the sandwich, the one that we had just seen. So you keep bringing small amounts of charge, which is generated by rubbing, and transfer it to this knob. So from the knob, the charge comes down and it gets transferred to this inside the inner metal cup. It will live on this outer surface of the inner metal cup. Now that charge causes induction. So if this is negative charge, then the positive charges will accumulate on the other side, on the outer metal cup. Okay? They're trapped there, they're held in place because of this negative charge. The negative charges will hold the positive charges. Whereas the negative charges on the outer cup, they will separate and then they will go away. They'll flow to the ground. Okay, so this way you can keep on bringing more and more charge, and that charge will move to this knob. And so in the end, we will have a lot of negative charge on the inner metal cup, a lot of positive charge on the outer metal cup, which is held captive. And when we can touch the inner cup and the outer cup, then these charges will rush towards each other and a lot of current will flow. So this way, we can charge the Leyden jar little by little and end up with a large amount of charge on it. Okay? It stores a large amount of charge and can be used whenever you need it. So here we are connecting the inner cup and the outer cup using a metal wire or a metal bar. There's a insulating handle attached. The brown one is the insulating handle, which is being held in the hand. Okay, so when I touch the outer cup to the inner cup, there's a big spark, a popping sound, and then all the negative charges will flow towards the positive charges, and all the charge stored in the Leyden jar will cancel out. It will discharge. So discharge happens with a big spark and a popping or a crackling sound. So this insulating handle is very necessary because there is a lot of charge stored in a Leyden jar, and if you touch it with your bare hands, then the charge will flow through your body and it is an unpleasant shock. So to spare yourself the shock, we use an insulating handle. So this is a version of the Leyden jar that we actually made. So this is just a plastic bottle filled with salt water. And through the cap of the bottle, we have inserted a stainless steel spoon, metal conducting steel spoon. And outside this bottle, on the lower end of it, we have wrapped aluminum foil. Okay, which is again, so the aluminum foil is the outer cup of the Leyden jar in this case, and the inner cup is this salty water. Water with salt is a conductor. So when I transfer negative or positive any charge onto the spoon, which is a knob, the charges will travel. They will enter water and they will travel through water and they'll end up on the inner surface of the bottle, and the bottle itself acts as the insulator. It prevents the positive and the negative charges from combining and cancelling each other. Okay, and then the outer surface of this aluminum foil is connected to the ground, so the negative charges will flow away, the positive charges will accumulate there. So I'm assuming that I'm charging Leyden jar using negative charge. I can also charge this using positive charge, using a glass rod rubbed with silk. Here is our Leyden jar. It's just a PET bottle, and there's a stainless steel spoon that has been introduced through the hole in the cap, and it's partially filled with water, to which 1 teaspoon of salt has been added. And there is aluminum foil has been wrapped around the outer surface of the lower outer surface of the bottle. It's been wrapped very tightly and throughout the all around the bottle, and there is this tail which has been attached to that outer surface of the foil. Okay? It's made of foil, which is a conducting material, right? So I place the tail on the ground, and there's a crocodile clip attached to it, so that I can I can touch it without because there's a plastic cover handle there. I can use it as a insulating handle. So I leave it on the ground so that the charges will flow away. Okay, so one charge will stay on the inner surface of the aluminum foil. The outer surface, the charges will flow away. Either electrons flow to the ground or electrons come through the ground. Now I rub the PVC pipe, and I want to transfer that to the Leyden jar by touching the knob, that is the spoon. So now the charge has entered the salt water, and it will accumulate on the inner surface of the bottle. It will move towards the inner surface. So this has to be done on a dry day, and you can hear small crackling sounds as the charge moves to the spoon. So I do this several times, maybe 20 times or so, to gather enough charge in the Leyden jar. After charging around 20 times, now I want to discharge the Leyden jar. So I'm going to touch the outer cup, which is the aluminum foil, and the inner cup, which is the spoon, is connected to the water. So the water is holding the negative charge in this case, and the positive charge is on the inside of the aluminum foil. So I'm going to use the tail itself to connect these two. I lift it up carefully, holding the plastic part, otherwise you can get a shock. So I touch it to the spoon. So there was a small spark, and there was a popping sound. There was a bluish spark. So let us look at it again after rewinding it. Sorry. So we are looking at it once again. So that looks like a tiny lightning bolt. I have charged this once again. So there was a more visible spark here and a very clear sound. That I have charged it for a third time, and let's look at the discharge once again. So you could clearly see a blue flash and a very distinct pop. So this was our homemade Leyden jar, which we charge and we discharge. You can do this using a glass rod with you can generate the charge using a glass rod and a silk cloth. It will work just like this. So Leyden jars have been around since 1745. That is when they were invented. They were invented through an accidental discovery, like many things. And then scientists started using a Leyden jar to store a large amount of charge and carry out very impressive demonstrations. Okay, so they Okay, so once it was possible to generate and store a large amount of electric charge, they carried out these demonstrations to the general public. So before that, only scientists had a reason to study electricity. It was not of any interest to the common people. But when the scientists started making these demonstrations to the public, people also got to know about electricity. So this is one example where the English scientists charged a Leyden jar, then sent these wires across the river Thames, and then they caused the discharge on the other side of the river. So the charge would travel all the way from the Leyden jar and then move back. Okay, so this huge sparks would happen, and people would be impressed. And the French scientists also, they made some very impressive demonstrations before this French king. So this is how people got introduced to the existence of electric charge. In the 1750s, Benjamin Franklin, who was a scientist and a politician in America, he charged a Leyden jar with electric charge from the clouds during a thunderstorm. Once the jar is charged, we can use the charge to carry out any experiment. Okay. So what else could we do? So this is what the scientists did. They checked, they explored various things. So they used a Leyden jar and passed the electric charge through water. Okay, we have seen electrolysis of water. We passed electric current through water, but we used a electric cell. Okay, but this happened before that. So they did this experiment. It was first done using a Leyden jar in 1789 by some Dutch scientists. So they passed the electricity through water and using these two terminals. So what electricity flows from one terminal to the other terminal through water, to which some salt or acid is added. So we know that hydrogen gas is produced at one terminal and oxygen gas is produced at the other terminal. This is electrolysis of water. Okay, so we can use the Leyden jar to light up a bulb. Okay, we used an electric cell to light up a bulb, and that's a steady flow of current, and so the bulb glows steadily. But when you discharge the Leyden jar through a bulb, then a small but a strong current short. It's a momentary current. So the bulb flashes briefly. Okay, so this is Franklin's experiment. So what exactly did he do? He used to work with Leyden jars. He has seen flashes of light, sparks, popping sounds, crackling sounds in his laboratory. And when he looked up at the lightning and thunder in the sky, he guessed that it could be the same. He made a hypothesis that lightning is nothing but the discharge of electricity between clouds. He said electricity forms in the atmosphere, and when the clouds rub, then these charges are transferred between the clouds and the sparks form, and that is lightning. So he wanted to test this idea. So this is Franklin's experiment. He flew a kite just before a thunderstorm was about to happen. So when there is a storm with a lot of high wind and the clouds form and the electric charges form in the atmosphere. So the kite was at a place where the electric charge had formed. Okay, and he waited under a shed till the rain arrived. So once it started raining, the kite string became wet, and a wet kite string will conduct the charges. So the charges which were there up there, they traveled down the string and they reached close to Franklin. But he was he was dry, and the last bit of string was also, which he was holding, was also dry. So the charges did not reach him. So he did not get electrocuted. He did not get a shock. But he had tied a metal key to the end of this string. So the charges came all the way till the metal key. And if when he brought other metal objects, using a insulating handle, when he brought them close to this key, sparks would fly between them. That means charge is moving from one object to the other. So he verified that there is electricity coming down from the clouds, at the same time protecting himself. And he touched the metal key to the Leyden jar, the knob of the Leyden jar, and he could verify, he could check that Leyden jar got charged. So Benjamin Franklin managed to bottle lightning in a bottle. He could manage to trap some lightning in the bottle. So he understood that lightning is an electric discharge, and just like the sparks produced in his laboratory, when a Leyden jar is discharged, lightning happens. Okay, so do we still have Leyden jars around us? Yes, we do have them, and they're very much still in use and very useful. We call them capacitors. And these capacitors are very small, and they are part of all our electronics. All electronic devices have capacitors. Capacitors are nothing but tiny Leyden jars, and their purpose is the same. They store electric charge. Okay, we stop here.